Okay, guys. Hello again. So in this lesson, we will be continuing. We'll continue looking at free falling bodies, motion, one-dimensional motion. So 1D motion is still what's interesting us right now. 1D motion. Okay, so let's talk about vertical motion. Okay, vertical motion. Vertical motion. So I'm just gonna jump right into it and start giving you equations that model the different variables that go into vertical motion, to 1D motion. There are only basically three variables that are going to interest us in terms of vertical motion. So we are only going to be interested in three variables. These three variables are position, uh, time, and velocity. These are going to be our only three variables that are going to be interesting us at the moment. And well, the equations that actually work with these three variables are the following. So let's call this equation 1. Let's call this equation 2. Oh, equation 2. And let's call this equation 3. And we'll have equation 4. Let me change colors. Magenta. Okay, so equation 1 is going to relate velocity with acceleration. So velocity in the y direction is going to be my initial velocity, so v0 in the y direction, times, so this velocity plus acceleration times time. That is my first equation. If I pass initial velocity to the left, I get Vy minus Vo. So Vy minus Voy is equal to A times time. And this is equal to my delta, and velocity in my y direction is equal to acceleration in the y direction times time. My second equation is going to relate position to velocity and acceleration. I believe we already saw this one. Let me just write it again. Y is equal to 1/2 my acceleration times my time squared plus Voy times time plus my original position, y0. If I pass y0 to the left, I am left with y minus y0 is equal to 1/2 at squared plus Voy times t. And we know that y minus y0 is delta y is equal to 1/2 at squared plus Voy t. My third equation is delta y, and this equation is obtained by substituting uh, this equation into this equation. So delta y is equal to, you can do the math by yourselves, I don't want to waste time on that right now. So this is Vy plus V0y. We can do the math if you want in class. I mean, if at least one person asks, I'll do it in class. But if you're not interested in the math, in the underlying math, this equation number 3, is obtained by substituting this equation, okay, into this equation, okay. And my final equation relates only velocities. It does not have to do anything with time. So Vy squared is equal to my original velocity in y squared plus 2 times acceleration uh, times my change in position. Okay, this one does not involve time. Look at it. So equation 1 has time, equation 2 has time, equation 3 has time, and equation 4 does not have to do anything with time. It's only relating my velocity, my initial velocity, my acceleration, and my change in position between 2 points. Okay, so this final velocity will obviously have to do with my change in position. Okay, so these are the 4 equations that we'll be using for vertical motion. I think that the most important equation, so the equation that we'll be using the most, is equation number 2. Okay, so take note of all of them, but equation number 2 is going to be the most important one. Maybe equation number 1 is also going to be important. Equations number 3 and 4, I mean, you can obtain them by a combination of equations 1 and 2. So actually the most important ones are equations 1 and equations 2. Okay, these two, you can write them down, but I think these two are the most important. So let's see how much time. I guess I'll stop here. Oh no, wait, I think we can do an example. So let's create a new example, new layer. Okay, there we go. Okay, so let's look at a quick example. No, you know what? I think I'll stop it here.